Okay, this is May, June 2021, paper 3-1. This first question is about the modulus function. Okay, when I have a modulus on both sides, I can either choose to sketch it wrong or I can just square both sides. That removes the modulus. This becomes 4x minus 1 whole square to x squared plus 2x plus 1 for 9x squared minus 6x plus 1 x squared plus 2x plus 1 36x squared minus 24x plus 4 x squared plus 2x plus. Bringing everything on one side gives me 35x squared minus 26x plus 3. I get two values for x, 3/5 and 1/7. Now, since this is a quadratic inequality, in order to answer this question, I will take the help of a sketch. This value is 1/7, this value is 3/5, and the values that are less than 0, so I should below the axis, and my final answer should be between 1/7 and 3/5. Okay, that is question number 1. Question number 2, it says find the real root of the equation this, giving you an answer correct to 3 decimal places. So whenever you have an exponential equation, these questions are about substitution. First, I'm going to cross multiply this and get this. I can solve it further, bring everything to one side, or I can just keep it on the other side. Let's just keep it on the other side. E power minus x. I'm just going to subtract the terms. Now, whenever you have such questions, they cannot be solved directly. What you need to do is you need to take the help of a substitution. So I'm going to take the substitution u equals to e power x. So this becomes u, this becomes 1/u. Because e power minus x is 1/e power x. This gives me u square plus 6u. U square plus 6u minus 1. Okay. Then I need to solve for u. 1, 6, and minus 1. So I get two answers for u. 0.1623 and minus 6.1623. Okay. So replacing u with 0.1623 equals to e power x and minus 6.1623 equals to e power x. This is not possible because exponentials can't be negative. ln on this side gives me x. So x is therefore correct to 3 decimal places, ln 0.1623. It's minus 1.818. Correct to 3 decimal places. This next question is about trigonometry. I start with trigonometry cos x cos 30 plus sin x sin 30 equals to 2 sin x cos 30 minus cos x sine 4. This gives me a root 3 over 2 cos x sine x 2 root 3 over 2 sine x half cos x. So I have calculated the values for sine 30, cos 30, and so on. I can get rid of all the 2's in the denominator. That sort of simplifies my expression. I get 2, 3 cos x plus sine x 2 root 3 sine x minus 2 cos x sine x minus 2 root 3 sine x. This has to be a plus. 2 cos x minus root 3 cos x. So I get sine x divided by cos x gives me okay. Then it says hence solve the equation. So I can use this expression. What I need to do is I need to convert this expression into a decimal just to know which quadrant tan x is in. So I get 2 minus root 3 or 1 minus 2. This is minus 0.1087. So minus 0.1087. So I know that when I'm talking about tan being negative, I'm talking about quadrant 2, and I'm talking about quadrant 4. First, I calculate alpha tan inverse of 0.1087. I get 6.204. Unusually small answer. It's called 6.2 only. Okay, quadrant 2 is 180 minus 6.2, and quadrant 4 is 180, 360 minus 6.2. So let me check my answers after this to be sure that I've done them correctly. 353.8 and 180 minus 6.2 gives me 173.8. Okay, so this was question number 3. Quickly check our answers for question number 3, and then we'll go backwards from there to see if we've done all of it correctly. Yes, these answers are correct. Let's verify for question 2 as well. That's also correct. And question number 1 is also correct. Good angles. Now, whenever you have 1 with cos 2 theta, the trick is to use the identity that helps you cancel 1. There are 3 identities for cos 2 theta. And 1 minus 2 sine square theta. So in the numerator, I'm going to say it's 1 minus 2 sine square theta because it helps me cancel the 1. And in the denominator, I'm going to use 2 cos square theta minus 1 because it also helps cancel out the 1. So I get 1 minus 1, 1 minus 1 plus 2 sine square theta. 2 cos square theta in the denominator. This also everything cancel out. This two cancel out. So I'm left with sine square theta over cos square theta. This is the only reason it's a 2-mark question is that it's short. So I get tan square theta equals to uh, tan square theta. Okay. Then it says find the exact value. Now I know that I can replace this entire expression with tan square theta. So I am here to integrate tan square theta. And there I can't integrate powers of trigonometric functions directly. So I need to use an identity. So the identity that I know is 1 plus tan square theta is equals to sec square theta. So this gives me sec square theta minus 1. I integrate this, I get tan theta minus theta. Sec square theta integrates to tan theta, and 1 integrates to theta, 1/6 pi, and tan pi over 3 minus pi over 3, tan pi over 6 minus pi over 6. Okay. Tan pi over 3 is tan pi divided, just to be sure it's √3. And this one is √3 over 3 plus pi over 6. Okay, so √3 minus 3 over 3 gives me 2 √3 over 3. And pi over 6 gives me minus pi over 6. Let's check if our answers are correct. Yes, they're correct. Okay, so this next question is about solving a quadratic equation with complex numbers. So I'm going to use the quadratic formula minus b plus minus root of b square minus 4ac over 2a. My ABC are so minus b square 4ac so I get 2pi plus minus 4b I square plus 4q over 2. So I get 2pi plus minus 4 minus 4p plus 4q. I square equals -1. I can factor out the 4 and say that this becomes q minus p. Root of 4 is 2. So 2pi plus minus 2q minus p over 2. This 2 can factor out and get cancelled. So I get pi plus minus root of q minus p. Check if that's the correct answer. Yes, there are 2 answers. I can just separate them if I want. Then it says in an Argand diagram with origins O, the roots of the equation are represented by their distinct points A and B. Given that A and B lie on the imaginary axis, okay, which means that this entire expression is an imaginary number, which means that this is either 0 or less than 0. Find a relationship between P and Q. So can I simply go on and say that if the entire thing is an imaginary number, then Q minus P should be less than or equals to 0. Okay, I missed a square somewhere. This is for p squared. So q is therefore less than or equals to p squared. Why? Because the discriminant must be negative or equals to 0. Although this question says that shouldn't be equals to 0. Okay. Given instead that the triangle OAB is equilateral, express Q in terms of P. Now OAB is equilateral. The roots are represented by the distinct points. So what were the two roots? Can I say that O is 0, 0, A is root Q minus P squared, and P, and B is minus and P. Okay. Now there are various ways of proving that this is an equilateral triangle. One of the ways of doing that would be to prove that OA and OB and AB are all have the same lengths. Okay, so I can do two things. I can use the distance formula to do this. Okay, I can calculate the length of AB. I can say that it's going to be root of P minus P square plus root of Q minus P minus P square minus root of Q minus root of Q minus P square. Okay, which gives me okay. So that simply boils down to 2 root of Q minus P squared. So the distance AB is root of 2 Q minus P squared. Okay, then I can take out the length of OA. That would be P squared plus root of Q minus P squared whole square. That gives me P square minus p square plus q gives me root of q. So 2 root of q minus p square equals to root of q. Squaring both sides gives me 4 q minus p square. It's an exhausting question. 4q minus 4p square equals to q. I get 3q equals to 4p square plus q in terms of p. Okay. I just found out two distances and I equated those two. Then there's question 6. This is about parametric equations. It says show that the gradient of the curve is always positive. So dx over dt is 1 over 2 plus 3t into 3. And dy over dt is a quotient rule. And this is going to quickly do the quotient rule here. U dash is 1. V dash is 3. So I get dx over dt equals to 3 over 2 plus 3t. And dy over dt is u dash v minus v dash u over v squared. Then I apply the chain rule. Dy over dx is dy over dt divided by dx over dt. Dy over dt is, if I simplify this, this comes out to be 2 over 3 plus 2 plus 3t whole squared. The 3t and 3t get cancelled. 2 over 2 plus 3t whole squared. Okay, when I change this divide sign into a multiply sign, I still divide. This becomes 2 plus 3t over 3, 2 plus 3t whole square. This cancels out with that, and I'm left with 2 over 3, 2 plus 3t. So I have to prove that the gradient of the curve is always positive. Now, somehow I have to prove that this is always positive. If I look at this expression is also here. And for logarithms, it's necessary that this expression must be positive. So since 2 plus 3t is positive for x to be valid, dy over dx is also positive. Okay. Let's just find the equation of the tangent to the curve at the point where it intersects the y-axis. That's dy over dx. I want it to intersect at the y-axis. That means x has to be 0. So x is ln 2 plus 3t. So when x is 0, e power 0, 3t is minus 1, t is minus 1/3. So I can calculate the gradient at this point. Gives me 2 over 3. And then I can find out what the y coordinate is. T over 2 plus 3t. So using the formula for the equation, which gives me y plus 1/3, 2/3, x minus 0. So I get 2x over 3 minus 1/3. Okay, that's the correct answer. This next question looks as if it's going to be about numerical solutions. First, it says the diagram shows the curve and its maximum point M. So I'm asking you to find the maximum point, which means I'm asking you to find dy by dx. Again, I see that the quotient rule applies since I have two expressions dividing each other, tan inverse of x and root of x. The differential of tan inverse of x is 1 over 1 plus x squared. And the differential of root x is 1 over x. Okay. So dy by dx is u dash v minus v dash u over v squared. Okay. Huh. Since this is the maximum point, I can say that this is going to be equal to 0. So the denominator gets cancelled out. I need to replace x with a. So, and take it to the other side as well. Tan inverse of a or 2 root a 1 plus a squared. So shuffling around gives me tan inverse of a. 2 root a into root a gives me a. 2a over 1 plus a squared. So tan inverse of a is 2a over 1 plus a squared. That is what I wanted. I just need to take tan to the other side and say that this is going to become tan of 2a over 1 plus a squared. Okay, then it says verify the calculation that a lies between 1.3 and 1.5. So what I can do is I can create a function of a and say that this is going to be this. Let's calculate f of 1.3. Okay, 1.3, my calculator needs to be in radians. Tan of tan of 2.6 or 1 plus 1.3 square. Okay, I get these two values. When there's a change of sign, that indicates sign indicates truth. Okay, the first task that whenever you're doing this question is to use this proof to create a function. That's what I created, and then I inserted 1.3 and 1.5. The next one says that use an iterative formula based on the equation in part one. So this was the equation in part one. I can create an iterative formula and say that this is an plus one. This is an, and I have an square in the denominator. I'm going to use the starting value of 1.4, the midpoint of the interval that I just calculated, the midpoint of 1.3 and 1.5. I need to give each result to 4 decimal places and alpha correct to 2 decimal places. So I'm going to use my calculator to come up with all these iterations. I need to have my calculator in radians again to answer over 1 plus answer squared. So the next iteration that I'm getting is 1.3865, which is 1.39, 1.3951, which is 1.40, 1.3896, which is 1.39, 1.3931, it's also 1.39, 1.3909, is also 1.39. So this, since this was repeated thrice, is 1.39. Okay. This next question is about vectors. It says with respect to the origin, all the points A and B have position vectors given by this and that. The line L has equation this. Find the acute angle between the directions of AB and L. If I want to find the acute angle between them, I have to use the formula cos theta equals to B1 dot B2 over magnitude of B1 into B2. B1 and B2 are the directional vectors. I know one of the directional vectors, that's 1 minus 2 and 1. For the second directional vector, I'm going to calculate AB, which is OB minus OA. OB is 3, 1 minus 2, 1, 2, 1. That gives me 2 minus 1 minus 3. 2 minus 1 minus 3. Taking the magnitudes of both, I get 1 square, 2 square, 1 square, and 2 square, 1 square, and 3 square. In the numerator, I have the dot product, which is 2 plus 2 minus 3. The denominator, I have 4 plus 2 is 6, minus 4 is 13, and 14. I use that to calculate theta. (83.7 degrees). So an easy form of question. And just find the position vector of the point P on L such that AP equals to BP. Okay, so let me write the coordinates first. OA is 1 to 1. OB is 3, 1 minus 2. And R is, if I were to write this as general coordinate, 2 plus lambda, 3 minus 2 lambda, 2 plus lambda, 3 minus 2 lambda, and 1 plus lambda. So P can be any point on the line R, which means that it's going to have the general coordinate. What I need to do is I need to find a value for lambda that gives me these two distances as equal. So if I want to calculate the distance AP, I'm going to say that it's simply going to be 2 plus lambda minus 1 whole square, 3 minus 2 lambda minus 2 whole square, and 1 plus lambda minus 1 whole square. I simplify this, I get 1 plus lambda whole square, 1 minus 2 lambda whole square, and lambda square. Similarly, I need VP. And to use the coordinates of R and B in this case, 2 plus lambda minus 3 whole square, 3 minus 2 lambda minus 1 whole square, 1 plus lambda minus 2 whole square. So I get lambda minus 1 whole square, 2 minus 2 lambda whole square, lambda minus 1 whole square. This is going to be plus 2 lambda plus 3. Okay, then AP and BP need to be equal. Okay, canceling at the roots, this gives me 2 plus 1 plus 2 lambda plus lambda squared plus 1 minus 4 lambda plus lambda squared plus lambda squared plus 4 lambda squared, sorry. 1 plus 2 lambda plus lambda squared. Actually, I've messed up the expression on this side. So I get lambda squared minus 2 lambda plus 1 plus 4 minus 8 lambda plus 4 lambda squared plus lambda squared plus 6 lambda plus 9. That's a long calculation, so do it carefully. 6 lambda squared minus 2 lambda plus 2. 6 lambda squared minus 10 plus 6 is minus 4 lambda. 1 plus 4 is 5. 5 plus 9 is 18. So what I'm getting is, I'm not sure this is the correct answer though. I will have to check. Lambda equals to 5.5. Because there's a lot of calculation involved, a lot of expansion involved, algebra involved, and it's complicated algebra as well. Let's just quickly verify our answer. This is lambda should equal 6, which means I made a mistake somewhere. Let's first compare our expressions. 1 plus lambda, 1 minus 2 lambda, and lambda squared, lambda minus 1, 2 minus 2 lambda, lambda plus 3. So there's some other mistake. Let's quickly verify that. is 1 plus 2 lambda plus lambda squared, 1 minus 4 lambda plus 4 lambda squared. Oh, this is 7 lambda squared. 6 lambda squared. This is a small error. It's 14. So I get 6. Okay. Once you get 6, I want to find the position vector. So I insert it back into the general coordinate. 2 plus 6, 3 minus 2 into 6, and 1 plus 6. So I get 8 minus 12 plus 3 is minus 9 and 7. So the general coordinate of P is 8i minus 9j plus 17. Small mistake can lead to a wrong answer. Okay, then this one says that the equation of y is this. The curve has one stationary point, find the exact coordinates of the stationary points. So this is the product rule. U dash is minus 2/3 x minus 2/3 minus 1. V dash is 1 over x. So I get minus 2x power minus 5 over 3 over 3. dy by dx is u dash v dash. U dash v. V dash. So yeah, and this I need to place equals to 0. And what I notice is that this becomes, when I add subtract the powers at the bottom, this becomes minus 5 over 3. So I can actually factor out minus 5 over 3. This gives me minus 2 ln x over 3 plus 1 equals to 0. So either this equals to 0, as the question might be telling me is not possible because x is greater than 0. So not possible. Or this one is equals to 0, which seems possible. So 1 equals to 2 ln x over 3 ln x equals to 3 over 2, and x equals to p power 3 over 2. Okay. Find the exact coordinates. I need the y coordinate as well. So y equals to e power 3 over 2 power minus 3 over 2 minus 2 over 3 ln e power 3 over 2. So this cancels out, this cancels out. I get 1 over e, and here I get 3 over 2. That's 3 over 2e. So the exact coordinates are e power 3 over 2 comma 3 over 2e. Yes, that's the correct answer. Then I need to integrate this as well. Now this is what we call integration by parts. When you're doing integration by parts, you use something called ILATE. ILATE is an acronym that tells you which one to take first. So this is ln x. I have logarithmic and I have algebraic. So the logarithmic becomes u and the algebraic becomes v dash. U dash becomes 1 over x. V becomes x power minus 2 over 3 plus 1 divided by the new power. So this becomes 3e power 1 over 3 U is ln x. 3e power 1 over 3. X power, sorry. I don't know why I wrote e x. Okay, 3x power 1 over 3 and u dash is 1 over x. So this boils down to in the same expression. I can pull 3 outside. I can say that this is going to integrate to so it becomes 9x power 1. Then I need to apply the limits, which are 1 and 8. So applying the limits, 3 times 8, 1/3, ln 8 minus 9 times 8 times 1/3 minus 3 into 1. ln 1 is 0. So that tells me that entire thing will be 0 as well. I get 6 ln 8 minus 18 minus 0 plus 9. 6 ln 8 minus 9. ln 8 can be written as 2 cubed minus 9. 3 comes down, 18 ln 2 minus 9. That's what I wanted. The next one is about differential equations, and that's the last question on this exam. This says the variables x and t satisfy the differential equation this using partial fractions. So I need to use partial fractions. So I'm going to bring this to one side first. So this is dx. There's 1 and there's dt. X equals to 1 when t equals to 0. So first I need to do partial fractions for this. So I'm going to start doing them on the side. I'm going to say that 1 over x squared 1 plus 2x can be broken down into 3 partial fractions. In the case of repeated factor, okay, this gets multiplied with x and 1 plus 2x. B gets multiplied with 1 plus 2x, and C gets multiplied with x squared. Okay, then I use cover up. I say that first I'm going to take the value of x equals to 0 because this is equals to 0. So this becomes a into 0 into 1 plus b into 1 plus c into 0. So it gives me p equals to 1. Then I take this expression to 0 and say that x be value minus half on each I get. I should take the value x equals to minus half. Take the value x equals to minus half. 1 minus half 0 minus half. C times minus half squared. This becomes c over 4. C equals to 4. And I can take any random value of x because I have no more brackets to make, no more expressions that I could make 0. So I take x equals to 1, 1, 3, 3, 1. I have the values of b and c. So I say that 3 times 1 plus 4. This gives me 3a equals to 7, minus 1, minus 6. A equals to minus 2. So I have my partial fractions. I have minus 2 over x, 1 over x squared, and 4 over 1 plus 2x dx. I have 1 dt. I integrate on both sides. Minus 2 ln x plus, this is simple integration. This is again ln divided by 2, differential of the bracket is to t plus c. So I get minus 2 ln x minus 1 over x plus 2 ln 1 plus 2x equals to t plus c. X equals to 1 when t equals to 0. So c equals to minus 2 ln 1, 1 over 1 plus 2 ln 3. So c is equals to 2 ln 3 minus 1. I just need to find an expression for t in terms of c. So this is a simple question. I can just move c to this side and say that this is going to become plus 1 minus 2 ln 3 equals to t. Okay, it's a long expression. I can combine this expression into one, and this is what the numerical scheme probably tells you to do. We've combined this expression in any form. So I can leave it at my form and still get complete marks for this. Okay, so even if I wanted to combine, it isn't very difficult. I can just say that it's going to become I can gather terms together. I can say that this is minus 1 over x. I could factor out the 2 from all the ln's, and I can say that this is ln 1 plus 2x minus ln 3 minus ln x. And then there's a plus 1 outside as well. This plus 1. And I can say that these ln's sort of combine together and give you this. That's equals to t. I would leave it in this form as well, and we get full marks for this. Okay.